And we are rolling on May 30th, 2017 here at UCLA. It's a beautiful day, a little overcast, but the jacarandas are in bloom. And if you look through the jacarandas to the sky, it's quite a view. Today, we're going to have a debate on climate change. Specifically, we're asking the question, scientists using computer models are able to accurately predict future climate events. Scientists using computer models are able to accurately predict future climate events. For the government, Michael and somebody, Yung Shun, and on the opposition, Karina and Tanner. And do I have a... Are you timing?
You want me to?
Yes.
I would love to.
Okay.
Give me a second. All right.
Okay. The chair calls this house to order for the leader of the government, Mr. Sir Michael, for a speech not to exceed 7 minutes in length. Here.
Okay, so we're here today for a Fact 3 debate, and I'm representing the affirmative side for the topic scientists using computer models are able to accurately predict future climate events. As a fact debate involving the factual validity of the claim, we propose the criterion for this debate to be based on the preponderance of meaningful evidence. And due to the factual nature as well agreed upon definitions are vital. So our definitions are scientists, a person who is studying or has expert knowledge of one or more of the natural or physical sciences. Computer models, using past and current data run through computer programs that predict what will happen in the future. Accurately, how close a result comes to the true value. Future, the period of time following the moment of speaking or writing. Time regarded as still to come within 20 or so years. And climate events. Any climate changes, events, or trends relating to global warming. There are burdens on both sides. We as the affirmative must show that there are scientists that can accurately predict future climate events with the use of computer models. If a scientist can take multiple flawed models via interpreting and properly piecing together their accurate parts, can accurately predict future climate events, we have met our burden. This also includes models that survive hindcasting that can also be considered accurate, which will be explained by Yunshin. And for the negative, they must show that scientists using computer models cannot predict these future climate events. They must show not only can models be flawed, but also that scientists cannot minimize these inaccuracies to make valid predictions. Because this claim addresses computer models and the ability of scientists to understand them, not that one model or one scientist can do this alone. So starting with the first argument is a logical argument that the past influences the future. So looking at terms, in simple terms, if a student has gone to the first 4 weeks of the quarter, we can assume that there is a high likelihood that will influence them showing up to the 5th week. Now relating back to global warming, one is that glaciers and ice caps have been melting for the last 35 years, showing a large-scale change in Earth's climate system. This suggests a link to the future as it has become a consistent pattern. With this knowledge, we can understand what is and has been going on as an indicator for what can possibly happen. In this case, being melting until there is no ice left. A second research shows the Milankovitch cycles, which, according to information provided by University of Southern Denmark in 2015, today Earth is affected by fluctuations called the Milankovitch cycles. There are 3 different cycles, and they occur each 20,000, 40,000, and 100,000 years. Over the last 1 million years, these cycles have caused ice ages every 100,000 years, and right now we are in the middle of a warming period that has far lasted 11,000 years. If Earth has been in these cycles for so many years, that provides vast amounts of information on how the climate was during similar conditions today. The second argument is that current technologies have already been able to make predictions of climate that are relatively accurate. In 2013, The Guardian reported that global warming since 1990 has fallen within the range of IPCC climate model projections. They state that since 1990, global surface temperatures have warmed at a rate of about 0.15 degrees Celsius, within the range of model projections of about 0.10 to 0.35 degrees Celsius per decade. The actual number falls within the prediction, proving the models to be accurate. From that same IPCC 1990 report, the report offered a best estimate of an increase of 2 degrees Fahrenheit by 2030, which at the halfway point in 2010 translates to a warming of 1 degree Fahrenheit. This further proves that this prediction is already on its way to becoming accurate. Furthermore, a study by Miles Allen and colleagues at Oxford University compared climate forecasts that began in 1996 with the actual temperatures observed since. They found that the simulations accurately predicted the warming experienced in the past decade to within a few hundredths of a degree. Second, models are always improving. However, that does not mean the current technologies cannot accurately predict. Currently, scientists use several models as cross-checks to create possible alternative scenarios for the future for some aspects of climate. Virtually all climate models concur to consistent results, lending a high degree of confidence to their accuracy. Computer models this shows that aspects of models can be highly accurate, while the less confident aspects can be analyzed through scenario comparison. Of course, models can always have improvements because it is like any other piece of technology, but that does not mean they cannot be accurate. A third argument is that inaccuracy does exist, but is minimized through our use of comparing different models and their simulations that allow scientists to still come to accurate predictions. The use of multiple scenario simulations works in decreasing inaccuracies in model predictions. Essentially, scenarios take into account different assumptions of how other factors, such as social consciousness to climate change, may have an impact on future climate results. For example, with increased social consciousness, the level of CO2 being emitted may decrease with the increased use of environmentally safe products, which in turn would change the climate's future, as it is one factor that would be different than using the current level of CO2 emission today. These scenarios take into account factors like this that may change over time. Lomberg discusses the factors that IPCC began using for these scenarios in 2001. The scenarios are distinguished on two dimensions. One primary dimension is whether the future will be most focused on economic or environmental development. The other primary dimension describes the degree of global or regional orientation. The economic global scenarios are further divided into three separate scenarios. One is fossil fuel intensive, one is balanced between fossil fuel and non-fossil fuels, and one will eventually make a transition to non-fossil fuels. The use of these scenarios allow us to make a range of predictions, as it is impossible to know exactly what the future will be like. This makes it possible to make predictions while still considering uncertainties. There is now, in 2013, according to climate.gov, a new set of scenarios, although it is still important to note the last ones, since a lot of the predictions that were made in the past were based on the scenarios. But since 2013, climate scientists agreed upon a new set of scenarios that focus on the level of greenhouse gases in the atmosphere in 2100. It is important to point out these different scenarios used, as they all work in decreasing accurate results, which is also why many of these accurate predictions that are made are ranges, because it's impossible to know exactly how the greenhouse gases are going to change. So we can at least provide a range that the number can fall between there. So on balance, in addition, one example, because we have shown there are scientists and models that can do it, we have proven our claim, therefore fulfilling our burden of proof. Nowhere in this topic does it state that all scientists and all models must do this, so because we have shown that some of them can, you should vote for the affirmative.
Thank you.
I now stand open for cross-examination and points of clarification.
Excellent. Thank you for saving me the words to say that. Chair will now hear from I guess you're the leader of the government?
Yes. Opposition.
Opposition. Leader of the opposition? We've never decided to switch the other way, have we? Have the deputy do the first cross-ax. Okay, good. Let's go.
So you have stated that glaciers and ice caps have been melting for the last 35 years, suggesting that they will continue to melt and not suddenly stop. Is this correct?
That's correct.
Okay, but did you know that a new NASA study found that an increase in Antarctic snow accumulation that began 10,000 years ago is currently adding enough ice to the continent to outweigh the increased losses from its thinning glaciers, meaning that the Antarctic ice sheet showed a net gain of 82 billion tons of ice per year between 2003 and 2008. Would you still say, after learning this information, that the glaciers are going to continue to melt and not stop?
I would have to look at that information for myself to decide if I would agree with you.
Okay. You've also stated that understanding past climate change is vital in creating future predictions. Are you aware that climate models have predicted that the rising CO2 emissions would increase global temperatures, which would melt the ice in Antarctica, but the ice area has, in fact, been increasing since 1979? How could accurate past predictions be vital in predicting future climate change?
Well, it's not necessarily in every single case, but there are definitely, it's not saying that, what happened in the past will happen in the future, but we can look at things that happened in the past and take those into account for, future predictions.
Okay. Did you know that the IPCC failed to account the pause in global warming, admitting that this happened because they did not predict it in their computer models? Wouldn't you agree that it is a little odd for a computer model that is supposed to decrease inaccuracies in model predictions to miss such a significant concept?
I guess, but in my brief, there was still an IPCC report that was still accurate in its predictions.
You have said that past predictions based on models have been proven to be accurate today, but an early draft of the IPCC report leaked in 2013, which included both projections and observations of climate change, had significant flaws due to the projections not being aligned to the models. What if other past reports that were published also contained similar flaws?
I'm not sure.
Okay, no further questions?
Okay, you have 1 minute left? She had 1 minute left?
Yeah.
Okay. Good. Thank you. Chair will now recognize the leader of the opposition for a speech not to exceed 7 minutes in length.
Hi, I'm Karina. I'm the
Hi,
leader of
Karina.
the opposition. And Michael went over the definitions that we all agreed on, as well as the resolutional analysis. And our criterion would be that since we are a fact debate, we should be assessing the truth, that the arguments be delivered on facts and statistics that come from credible sources and scientists who are credible and expert in their fields. The debate should be judged based upon the preponderance of meaningful evidence that is presented more convincingly and accurate. We would also like for the audience to decide in terms of the quality of the evidence presented, meaning that it should come from credible sources, allowing the audience to decide which is more convincing. So what is the problem? The problem is that many computer models overestimate the impact of global warming and various other climate events, which are becoming an increasing concern in the world, and we are having this debate to see if the data from computer models accurately supports the predicted climate events in the upcoming future. So the number one claim is that due to the vast and unpredictable nature of the atmosphere, we can never be certain about climate events. This comes from the evidence that if we could measure the weather at every instance in time, at every point in the Earth's atmosphere, then we would be able to determine the behavior in the future. But because we can only approximately predict the weather, such as wind direction and speed, the future weather is unpredictable. This goes back to the chaos theory, which can be best summarized by Edward Lorenz, when the present determines the future, but the approximate present does not approximately determine the future. How many times did you hear that tomorrow will be sunny and warm, but it actually turned out to be cloudy and cold? It cannot be said with certainty on which day will rain or on which day will snow. According to Jesse Liu from Institute of Physics, this mismatch of predictability is in fact a consequence of chaos.
5 minutes.
Over the long term, daily weather regimes becoming unpredictable. Predicting global temperature change is hard, especially with all of the factors that affect how much energy the Earth reflects and absorbs, one of them being feedback mechanisms. In relation to climate change, a feedback mechanism is something affected by climate change, which itself makes climate hard to predict. And, for example, the heating of the Earth could make the ice caps melt, which could mean that less of the sun's light is reflected back into space, which could in turn cause the Earth's temperature to rise even faster. But some feedback mechanisms could slow climate change. Some could accelerate it. Either way, they make prediction harder and mean that scientists need to run many more models to get a feel for what is likely to happen. Due to this, computer models miss major climate features such as El Nino, tropical rain, and the cycle of tropical winds and rain. According to IPCC researchers, this is because the simulations are so coarse, the mesh is too big to capture details, and important processes such as cloud formation and the carbon cycle need to be approximated. The limit after which weather forecasts lose their skill and become unpredictable varies and depends on factors like the background atmospheric flow constitution, the specific location and time of year. Detailed weather patterns identify the atmospheric state at a particular instant in time and space become unpredictable, on average, approximately after 2 weeks. According to Ante Weissheimer, a senior research fellow from the Department of Physics at Oxford, even though estimates of atmospheric quantities are used to initialize weather, forecast models are derived from real-world satellite and ground-based in situ observations of the current state. Their precise values are not known accurately, and thus have an inherent uncertainty associated with them. This brings me to my second point, that due to the unpredictability of the atmosphere and the inaccuracy of computer models, global warming has become overestimated. Climate models are amalgams of fundamental physics, approximations to well-known equations, and empirical estimates of processes that either can be resolved because they happen on too small a physical scale, or that are poorly constrained from data. In 2013, the Intergovernmental Panel on Climate Change, IPCC, flagged an odd phenomenon. Atmospheric temperature data collected over the past few decades suggest that global warming had slowed down beginning around 1998. During the 1980s and 1990s, new all-time record high anomalies were occurring about every 3 to 4 years. But then we hit the hiatus. The rise in the Earth's average surface temperature basically stopped. Global warming morphed into climate change, and it has been 16.5 years since the last all-time record monthly temperature anomaly was set. 95% of computer models failed to predict the hiatus that we're experiencing right now. Clearly, there are too many climate variables to create computer models with enough certainty upon which to make international policies that could radically alter the global economy. According to Lombard, there is no doubt that the temperature of the late 20th century is greater than many previous centuries, but this cannot be taken as a simple indication of overwhelming global warming. According to Stephen Corneliuson from the Center for Advanced Studies of Accelerators, what is not a known fact is that the warming numbers most commonly advanced are created by climate computer models built almost entirely by scientists who believe in catastrophic global warming. The rate of warming forecast by these models depends on many assumptions and engineering to replicate a complex world in tractable terms, such as how water vapor and clouds will react to the direct heat added by carbon dioxide or the rate of heat uptake by the oceans. From the beginning of climate modeling in the 1980s, these forecasts have, on average, always overstated the degree to which the Earth is warming compared with what we see in the real climate. My findings should persuade the audience to be skeptical whenever they hear predictions about global warming or climate events from computer models, since some are built for the exact purpose of overestimating the temperatures. I now stand open for examinations and points of clarification.
Thank you. Chair will now hear a cross-examination, not to exceed 3 minutes.
Okay, so you claim in your brief that we do not have enough data about the atmosphere to accurately predict. Then how is it that there are predictions that have been proven before, as some of them were stated in my brief, even with the missing data that you say is so vital?
Where is this in my brief?
Well, there was one of your assertions that we don't have enough data about the atmosphere to accurately predict.
Oh yes, well because the atmosphere is very unpredictable. There's chaos going on. We don't know exactly how the atmosphere works. We don't know exactly how the universe works. So we can never be certain how climate is going to work and how can we forecast something that we don't know exactly is going to happen.
But to answer my question specifically, it was how is it that there are predictions that have been proven to be accurate, as some of them stated in my brief and others that Yunshin will state later, even with the missing data that you say is so vital?
Well, there has been predictions that are also not proven correctly.
Okay. Also, since you stated heavily on that we should get our sources from credible credible like sites and things like that.
Yes.
So in one part of your brief, you stated that there are too many climate variables to create computer models with enough certainty to make international policies, which you cited from visionandvalues.org. And on their website, at the very bottom, it says that it is a conservative think tank strengthening the faith and freedom foundation of American citizenship. And also on the homepage has a picture of our Vice President Mike Pence, who already denies climate change. So wouldn't you say this is a biased source?
Which source is that?
Visionsandvalues.org.
Would I say it's biased?
Mm-hmm.
I would not say it's biased because the scientist, it's a person, the interviewed was a scientist from a
1 minute.
university.
Okay, we can go to the next question. Okay, then you also state that models have overstated the degree to which the Earth is warming compared to what we see. Do you know what time interval that they used to make that assertion?
Yeah, from the 1990s.
Okay, because from an LA Times article, it states that a lot of times these researchers will take smaller intervals starting in the 90s instead of starting like in the 70s. And when you start in the 90s, it actually always overestimates, but if they used a bigger interval, it would give a more accurate prediction.
Yes, but I believe that computer models were more accurate or starting to become more advanced in the 90s and 70s.
That's all I have.
Thank you, Mr. Shelley. It's now time to hear the deputy member of the government for a speech not to exceed 7 minutes in length.
Hi, I'm Lucian.
Hi, Lucian.
I'm speaking for the government side. As Michael has already gone through the definition, resolution, analysis, and criteria, I'll just go directly into my points. The 3 bullet points I'm going to argue is, first, there are currently models that can successfully predict climate events. Second, computer models have advanced with technology improvement, which have improved our accuracy. Third, scientists' understanding of the climate system is also advancing. Starting with the first, there are models that can successfully predict climate events. We know that some past predictions turn out to be false. There are, however, good predictions that are accurate enough. I'll introduce 2 kinds of models. First, model with successful past predictions. This has already been introduced by Michael, specifically the first consensus prediction made by IPCC in 1990. I'll focus on the second part, which is current new models, which survive hintcasting. Hintcasting is a commonly used method in scientific area, which assumes you were at a point in the past, and with all the data available at that time, make predictions of future from the past. And then we compare these predictions with the actual data we have and see how accurate it is. According to Charles Marshall, professor at UCB, the only way to test a model and improve the forecasting is through hintcasting. First, with hintcasting, El Nino, one of the main factors that influence climate events, are predictable with certain techniques. Dick Chen, a professor at Columbia University, found out that all of the prominent El Nino in the past 1.5 centuries could be predicted up to 2 years ahead, using a model that does not invoke any stochastic forecasting. This means that scientists have confidence in predicting future El Nino events with Professor Chen's model. Second, with hintcasting, scientists are able to predict that there is a correlation in sea surface temperature and hurricane intensity. Karen Manuel, a professor at meteorology at MIT, predicts that the hurricane intensity will increase 5% for each degree increase in tropical ocean temperature. 5. Thomas Knudsen from NOAA tested his model and found that the model worked for the last 30 years. So projections are made that intensity will increase by 2 to 11% by 2100. Actually, when Lundberg and our opposition side argues that the extreme events such as hurricanes are overestimated, they only focus on the number of hurricanes. It is actually the intensity of hurricane, not the numbers, that is influenced by temperature change. The second point I want to make is that computer models are advancing. They have developed a lot together with the technology evolution, and we have confidence in their ability to make accurate predictions. First, I want to introduce a multi-model ensemble, which is used by most scientists in recent years. CMRP5, standing for Coupled Model Intercomparison Project Phase 5, is a collaborative climate modeling process coordinated by WCRP in 2008. It consists of 20 climate modeling groups, each with a lot of sub-models. What scientists do is to choose certain predictions for certain models that works best for a specific condition. CMIP5 function includes decadal hintcasting and prediction simulations, especially for long-term simulations. It's not about daily events, but the long-term trend and long-term weather, so the predictions of which cannot be verified until years later. And the only thing we can look at is how good is its hintcasting. Its ability to repredict droughts was tested by Nashil Lehi, a PhD at UCI. He found that the observed trend in drought areas is reproduced by about 3/4 of the CMIP5 models when considering the total land areas in drought. Similarly, Christine Stiller and Francis Spires from Pacific Climate Impacts Consortium at University of Victoria, Canada, tested CMIP5's prediction on explosive cyclones. And they found that most models accurately reproduce the spatial distribution of explosive cyclones when compared to reanalysis data, with correlation coefficient 0.94. So correlation coefficient is a measure about how much two things are correlated, with -1 related to 100% negatively correlated, and +1 means 100% correlated. They're just the same thing if it's +1. So 0.94 means the prediction and the actual value are highly correlated, which means it is accurate. So we can see CMIP5 do successfully post hintcastings for various climate events. Because long-term accuracy cannot be verified directly so far, we can infer long-term accuracy through short-term prediction improvement. Peter Bell, Deputy Director of Research at European Center for Medium-Range Weather Forecast, says that numerical weather prediction accuracy has benefited enormously from computing advances. In terms of floating point operations, computing power has increased by about 1 order of magnitude for every 5 years since 1980s. And compared with the accuracy a decade ago, the 3-day in advance forecast skills has increased from 80% to 98%, which means we do know the weather for 3 days later. And 5-day forecast skill has increased from 60% to 90%. So short-term prediction improvement is due to technology development and scientists' increasing understanding in climate systems. With the same development in technology and understanding of long-term climate systems, we can make an analogy from short-term to long-term and be confident that our long-term prediction is very likely to be accurate. Here comes the third and the last point I want to make. Scientists' understanding of climate system is advancing. Climate does have its variability, which is the main cause of uncertainty in climate change. But this has been studied a lot in recent years, and here are some examples of recent researches where various aspects of climate variability have been studied thoroughly. Michael Gill, professor at UCLA, comes up with a treatment to model random effects for both nonlinearity and stochasticity, which means error caused by noise can be minimized. Gosser from University of New Mexico researched on seasonal and interannual variability. Seasonal climate variability is controlled by incoming solar radiation, while interannual variability can be organized into very large-scale patterns of wind and temperature fluctuations, and all of these can be put into models. Legao and Brett Bryan came up with 648 possible pathways of future sustainability, including climate change, with different possible future environmental, socioeconomic, technological, and political factors. So they're actually taking human activity into consideration when making predictions. From this, we can see scientists have really considered variables of climate system, and we really made a lot of progress these years. In assessing how those understandings of climate system have influenced our accuracy of prediction, James Harrow from National Center for Atmospheric Research on North Atlantic and Arctic Oscillation, also known as NAO, he found that correlation to prediction and the actual value was very high, as 0.92. So our advanced understanding has led to higher accuracy. I now stand for cross-examination and points for clarification.
Thank you very much.
Hi, Ucla. Okay. So you talked a little bit about hurricanes and measuring the intensity. How does your source measure the intensity of hurricanes?
My source comes from nature.
Look at the audience.
How do they measure the intensity of hurricanes?
I'm not quite sure about it.
Okay. So would it surprise you to learn that during El Nino years, there's only a 28% chance of 2 hurricanes making landfall with the U.S., but during colder La Nina years, there's over a 60% chance of 2.
Is it about the number of hurricanes or the intensity?
So are you saying that the ocean temperature has no influence on the number of hurricanes?
Actually, the number of hurricanes decreases if temperature increase, which is a common consensus of scientists for now. But we're talking about intensity.
Okay.
Sorry.
I think frequency is also important.
But-
CMIP5 models that you stated, would you be surprised to learn that, according to Ed Hawkins, in certain regions in the tropical Pacific, there are consistently plus or minus outside of the 10 standard deviations of the model, and that he also stated that climate models would never be able to capture all the variables. I might add that he was one of the people involved in making the CMIP5 model.
Okay, so what is the model he's talking about? Is it the general model of CMIP5, the multi-model consists of all the sub-models, or a specific model?
The CMIP5 model in general.
So it's the general
It consistently has not been able to predict tropical Pacific temperatures. And so, based on that, would you conclude that because maybe it is able to predict the past, but that doesn't mean that it can predict the future because it hasn't?
But there's no way you can see that CMIP5 can predict future, right? All the things we can rely on is on past.
So a study posted on the Climate Etc. blog by a reputable scientist looked at 3 models, CCSM3, FAMOS, and OOEIM, and all 3 of them failed to predict the temperature at any point in the Holocene period.
Okay.
And so therefore, is it safe to say that most models are unable to predict the past accurately?
First, you only have 3 models. Second, as I said before, certain models works really well in certain conditions. Say that there are some models who can predict really accurately at North Pole, others at South Pole. So if you're saying that these 3 models are they themselves are not able to predict accurately here, but maybe they have their accuracy there.
Should may I ask my next question?
So I'm talking about, no, I don't agree with you.
Okay. So you mentioned that failed predictions don't mean that we're unable to predict the future. Can you reconcile those 2 ideas?
Actually, that one was in my possible rebuttal. I didn't deliver it.
Mhm.
So, failed predictions doesn't mean that we're not able to make correct future predictions, because there are so many predictions in the world. There are some correct, some incorrect. If you're saying that these predictions are incorrect, they're false, and then you deny the ability of
One
the
last
other
question.
ones.
Thank you, Yushen. You cited a 1990 model by Frame and Stone,
We're done.
and you said that 1.1 degrees Celsius was the prediction by 2030, and at the halfway point in 2010 would be 0.55 degrees Celsius, and that in 2010 observed
Okay, your
temperature-
time was expired, Tanner,
Okay.
about 10-15 seconds ago.
Okay. I was just confused because you let Yushen talk for like 20 seconds. After.
10 seconds.
Okay, well, answer his question.
He didn't say his question.
So the point of the question is, so they grossly overestimated the temperature and you cited it as evidence for your point. I'm wondering, did you intentionally mislead the class or was it an accident?
No. It's okay, so my research actually came from Nature Climate Change. So David Frame and Daisy Storm, there are 2 professors. I didn't cite where they are here, but their comparison between the IPCC temperature and the actual temperature value has been published on Nature, so I take that as credibility.
Okay, that's enough. Thank you. Thank you for intentionally misleading the class, both of you. Okay, well, on that happy note, let's hear from the deputy member of the opposition, who will, I'm certain, not intentionally mislead us. Wow.
So, opening, a couple points that I want to make about models is that there are a vast amount of models that are incorrect. And assuming that some are able to make accurate predictions, if you're blindfolded and you throw enough darts at the dartboard, eventually one of them is going to hit the bullseye. So keep that in mind. And one thing about the credibility of sources is that everybody views the world through a certain lens, and I would postulate that based on the fact that 97% of scientists believe in climate change, that 97% of scientists, including those making models, have preconceived notions, agendas, and bias. So keep that in mind as well. So the majority of computer models are actually inaccurate at predicting the future. Three of the most prominent climate models, when fed data from the Holocene era, were unable to predict Holocene temperatures at any point. And the reason for that was stated is that all of these models overstate the importance of greenhouse gas on temperature change, and that they do not account for orbital variation, which has been responsible for climate changes all throughout the history of the Earth. The demonstrated inaccuracy of climate models has led the scientific community to stop predicting the future and instead make projections and possible futures, as stated by Bjorn Lomborg. The computer models have been inconclusive in predicting the future El Nino, with many predictions an increase in frequency of change, many predicting no change. So there's a huge conflict in the science about that. And I don't know, as most of you remember, not this most recent winter, but the winter before that was supposed to be an El Nino year. And all of the local news outlets predicted a very wet year, and it rained very little, so keep that in mind. In 2007, Al Gore, citing computer models, stated that summer sea ice would likely be gone by 2013. However, in August of 2013, NASA satellites observed a polar ice shelf that was more than half the size of Europe and 60% larger than the year before. Patrick Michaels and Paul Knappenberger concluded that 108 models used by the government for projections projected much higher warming than was actually observed since 1950. Roy Spencer, a NASA scientist, reviewed 90 climate models that made predictions spanning from 1979 to 2013 and concluded that no less than 97.8 of those climate models over-forecasted the temperature trend during this time period when compared to actually observed temperatures in the lower troposphere. The models used by scientists have inherent flaws. In 2014, Tim Palmer, a researcher at the University of Harvard, claimed that that uncertainty is substantial. He said current computer models don't have the capacity to calculate the global effects of the water cycle, and to bring down this uncertainty, it would take an entire new generation of climate simulators using supercomputers much faster than today, and the cost of developing these would be over $250 million. The historic temperature data used to create climate models is flawed, as much of the temperature is derived from North American tree rings, which only provide data from a single geographic area and exclude data from temperatures at nights over the ocean and in the winter months, as stated by Bjorn Lomborg. Again, NASA scientist Roy Spencer stated that climate models are only good as the assumptions that go into them, and they have hundreds of assumptions, and all it takes is one assumption to be wrong to throw the forecast way off. Models are also only as good as the data that goes into them. Patrick Frank, a scientist at the SLC National Accelerator Laboratory at Stanford University, published a paper that explained the errors recorded in temperature. He found that errors are over twice as large as generally recognized. And in 2011, he stated that 2004 global air surface temperature with 95% confidence is 0.8 degrees Celsius, plus or minus 0.98 degrees Celsius. And the error bars in the study were wider than the actually observed temperature change. So it's significantly possible that there has been no change at all. Professor Ian Clark at the University of Ottawa stated that any model that doesn't accurately include all components contributing to climate, including cosmic rays, solar activity, and that the model isn't worth anything. He also said that by tweaking the parameters of mathematical models, you can make models say anything. And with that, models that accurately predict the past, scientists can tweak the parameters to make models accurately fit the past, and that grossly affects its ability to predict the future, so there's a cost and benefit with that. Many aspects of the negative feedback within our climate system are not well understood. For example, as the world warms, forest fires become more common. But the negative feedback provided by forest fires includes a change in land surface that reflects more sun than darker forests, and also an increase in aerosols in the atmosphere that also reflect more solar rays. According to Bjorn Lomborg, the IPCC requires that all models refuse to consider a reduction in greenhouse gas emissions, even reductions due to treaties that have already been signed. This makes all models artificial worst-case scenarios. Scientists cannot model political factors that can contribute to greenhouse gas emissions and skew predictions. How much time do I have left? 1 minute? Scientists have a vested interest in creating models with political agendas. In 2015, Professor Judith Curry stated in a House hearing that a preferred policy stated by the United Nations in the 1990s marginalized research on broader issues surrounding climate variability. In 2009, the ClimateGate event, which was leaked emails of IPCC officials, brought to light something known as man's nature trick, which is a manipulation of data of tree rings, and that this proxy change was used to make models fit observed temperatures, and this was done to achieve political goals. Dr. Patrick Michaels, Director of Science at the Cato Institute, said that between 1992 and 2013, the U.S. government spent billions on climate research. He contends that government used the power of funding to give scientific research supports existing models that favor existing policies, and that they use this power to stifle contrarian views, and that creates a tremendous bias in the scientific community. Charles Driscoll, a researcher at Syracuse University, received $3.56 million of EPA funding for the purpose of supporting the Obama administration's Green Power Plan. He admitted to the Pittsburgh Post-Gazette that the findings of his study were predetermined, stating, "In doing this study, we wanted to bring attention to the additional benefits of carbon control."
That's time.
That's time.
I now
I now stand open for cross-examination and points of clarification.
thank you very much.
So in your first argument, you say that one scientist reviewed 108 models from CMIP5 and said that all of them failed to predict, right?
I didn't say they were from CMIP5.
But according to your source, I checked your source. They're predicting on CMIP5.
Over here.
Okay.
Okay, so do you know how CMIP5 works?
I have a very peripheral understanding
Okay,
of how
so
CMIP5 works.
CMIP5, as I
From what I understand, it works from
Over here, look over
taking
here. Yeah.
observed data from our climate systems, and it takes that observed data and the parameters programmed into it by scientists to make guesses.
Okay, so probably you didn't listen to my delivery. Okay, so multi-model for
Is that a question,
CMIP5.
or-
Yes, for the question. CMIP5 has tons, like hundreds of thousands of models. And it doesn't matter if 108 models failed or not. Because for a specific condition, we may only need to look at like 10 models that gives the accurate prediction for this condition. And if you want to look about the accuracy, I do have the evidence. Time?
No, 2 minutes.
So
So I guess I'll
let me let you know. Actually, studies found that the mean absolute error for temperature simulations used by certain models from CMIP5 from 1950 to 2010 by Hankins is 0.13 degree for Western U.S., 0.1 for Australia, 0.21 for Eastern China, and 0.24 for Europe. Do you think
Yes.
this is an accurate prediction? Like the error is really small, right?
From what I understand, is that the models used by CMIP5 use a baseline of 1% annual CO2 growth. Is that
Over here.
accurate? So based on that 1%,
It's
and
not accurate.
okay, so
So part of the models in CMIP5 use that, but the rest doesn't.
okay, so the
And
models
let's
that
move to the
you're
next question,
asking.
okay? I've already got things about it.
Thank you.
Okay. So for the second argument, you use 12 sources together. Do you realize that 7 of 12 sources are from Bloomberg, skeptical environmentalist from 1998? And the second argument you are arguing is that due to the limitation of first technology and second current understanding of climate systems, we are not able to predict the flaw because the models are flawed. These are the reasons.
So to answer your first question, yes, I am.
I didn't ask a question.
Yeah, you did. You said, are you aware that?
Okay.
Okay, so yes, I'm aware
Okay.
of how much I cited Bjorn Lundberg.
Got it. So, do you realize this is almost 20 years later? And you are using the sources from 20 years ago to say that technology is limited. And our understanding is limited.
Okay.
Think about it. In 1998, do we have like Amazon? Do you have Wi-Fi? Do you have Alphabet?
Yes. Yes, Amazon existed in 1998.
Okay. Is it like so pervasive? No, it's not, right?
Yeah, okay.
Okay.
So anyways, to answer the question that you asked, a lot of what I cited from Bjorn Lundberg aren't necessarily facts and figures. What it is are errors in the climate community and how...
This error is 20 years ago, right? And
Okay,
I'm
that's
gonna do this.
time. Thank
Sorry,
you.
I still
Thank you, Yusha.
I know, he got extra time. Okay, thank you very much. And that concludes the constructive part of this debate. And now it's time for refutation, in which we will see, hopefully, 4-part refutation. She said, I disagree because, therefore, models are great, or models suck. Begin.
Okay, Karina states the atmosphere is too unpredictable to make future climate predictions. However, we disagree because through the examples of proven model successes, like the 1991 that we referenced, and scenario simulations that take into account other factors, these uncertainties can be minimized enough to make an accurate range of prediction. Therefore, this claim is false. Karina also stated that global warming has been overestimated. However, we disagree because a study from the LA Times revealed that this overestimation is commonly due to biased researchers that take shorter time intervals that create these inaccurate results. Therefore, this argument is invalid as it was not fully proven by the opposition. And how Tanner was claiming that scientists have vested their interest in creating models which justify political agendas, but he failed to mention how there are scientists also on his side of the argument that do the same thing to create this illusion of overestimation. The opposition also stated that all the models overstate climate change, but do not provide enough specific examples of models that have done so. And going back to what our topic is, that scientists using computer models are able to accurately predict future climate events, it's saying that there are scientists that are able to do so, not that every single time that they're going to be accurate or that all scientists and all computer models can do so. We have shown our resolutional analysis by revealing how scientists can take multiple flawed models and effectively interpret them to come up with an accurate range of prediction. One example being the 1990 IPCC report discussed in the second part of my argument. Because we have shown there are scientists and models that can do it, we have proven our claim and therefore fulfilled our burden of proof. Nowhere in this topic does it state that all scientists and all models must do this. But since we have shown that there are some that are able to do so, we have proven our claim.
Thank you. You're here. And now the chair will hear from the leader of the opposition for a 4-part rebuttal. He said, I disagree because therefore. Yes, she knows that.
Michael says that glaciers and ice caps have been melting for the last 35 years, suggesting that they will continue to do so. I disagree because there is evidence that the ice caps are actually gaining pounds of ice per year from NASA in 2015. Therefore, past predictions cannot influence the future, which make computer models unreliable. He also says that there are climate cycles that have been repeated for years, and this allows for the data to be used for future predictions. I disagree because the atmosphere is chaotic, and therefore future predictions cannot be reliable due to the unpredictability of the universe, which we have not yet completely understood and figured out. Michael also says that future climate event predictions can be understood through past changes. I disagree because some past data and reports have been proven false or unreliable. Therefore, it is not a significant factor for future predictions as many computer models are flawed. The government also said that past predictions based on models have been proven to be accurate today. I disagree because these same exact models failed to predict the pause in global warming. Therefore, we cannot rely on past predictions to be as accurate as scientists claim them to be. They also said that models are always improving and current ones are still able to accurately predict climate. I disagree because even with today's technological advances and models, scientists are still unable to give an accurate forecast for the week. Therefore, these models are not reliable for future climate events such as global warming. They also said that multiple scenario simulations work in decreasing inaccuracies in model predictions, and I disagree because these simulations may actually be adding to the inaccuracies and flaws in computer models. Therefore, cannot serve as reliable predictions of future climate events. I believe that the opposition has met its burden of proof and used the credible and preponderance evidence. So I hope you guys will cross.
Thank you. Chair will now hear the deputy member of the government for a 4-part refutation. She said, I disagree because, therefore.
They say the majority of computer models are inaccurate at predicting the future. We disagree because the only criteria to prove that the majority is inaccurate is to count all predictions and all failed predictions and then calculate the percentage. And also the multi-model works such as CMIP5 works in a way that the failure of a large number of models does not affect the final prediction. Therefore, we question how did they come up with the conclusion that the majority is inaccurate. And we believe that the failure of predictions of lots of model in a multi-model system is very unlikely to affect the accuracy of the final prediction. They said the models used by scientists are inherently flawed. We disagree, because according to their argument, the accuracy of the prediction is limited by, first, limited understanding of climate system, and second, limited technologies I've already talked about in cross-examination. However, because of their source, it's from skeptical scientists, like over 50% of their source. A book published in 1998, almost 20 years ago. Given technology advancement these years and the increase in scientists' understanding of climate systems these years, I've shown you before. We believe their evidence are out of date, and therefore I question the credibility of their source. Therefore, those evidence fail to support his argument that the flawed models cannot be improved due to those limits. They also said that scientists have a vested interest in creating models which justify political agendas. We disagree. Actually, we're really surprised that the opposition side would propose such an arbitrary and disrespectful argument to all scientists. We disagree because this statement has two fallacies: false generalization and false correlation. First, the corruption of several scientists does not rule out the integrity of all scientists, nor does it rule out those scientists' ability to predict future. Using analogy, it's like if some students at UCLA cheat. Are you saying that all students at UCLA cheat? Second, receiving funding from government is not necessarily due to scientists meeting the demand of government or politicians. If you conclude they publish fake researches just because they get funding from the government, it's like if a student gets an A, you're saying you're definitely cheating. Therefore, it's inconsiderate and unreasonable to say that scientists have vested interest to create models satisfying political expectations need, and this sub-argument failed to support their position that future predicts as inaccurate. Is it time? We have shown you that there are past models that have made successful predictions for current world. We have shown you that current advanced models that successfully predict past events with the effort of scientists, and therefore we can put certain confidence in the performance of their future predictions. Science does have this limitation, but we can still reach some meaningful and accurate predictions over the long term. We have met our burden of proof by showing that there exists plenty of cases where scientists with their models can accurately predict our future events, and we believe our source credibility outperforms theirs. Thank you.
Thank you. And last but not least, it's time to hear from the deputy member of the opposition for a rebuttal in 4 parts, not to exceed 3 minutes in length.
So Michael stated that that his side, all they have to do is prove that any scientist was able to make an accurate model. I disagree with that because that is also a fallacy, because if you apply it to the other side, because I have several, 97.8% of all models were not accurate, so therefore I can prove that scientists cannot accurately predict climate with the same logic. So bear that in mind in making your decision. So, and also a point, Yun-Shun questioned the validity of the skeptical environmentalist, but I'd like to point out that I disagree with that. It is updated every few years. So we're not making generalizations about all scientists, but we were merely pointing out that there are certainly instances of monetary corruption of some scientists, and that we're advocating skepticism when looking at the results, and that going back to saying that all scientists, or all people for that matter, view the world through a certain lens, that should be kept in mind in looking at the sources for the government as well, and that reality is probably somewhere in the middle, which is still inaccurate. And there's nothing biased about looking at models and saying that 97.8% of them failed, because that's a fact, and that's not something that can be manipulated in any way. And then also stating that that I want to say that they cited the IPCC quite a bit, and I disagree with that because we've shown that it's a corrupt organization. Looking at ClimateGate, they showed that they have a past of manipulating data, and it's well documented. And I also wanted to point out that in 2014, Harvard professor and part of IPCC, Robert Stavins, found himself locked in a room with 2 scientists and 50 government officials, and they said, quote, he said of that, quote, any text that was considered inconsistent with their interests and positions in multinational negotiations was treated as unacceptable. So anything that you see from the IPCC, bear that with a grain of salt. Also, Yun-Shun also stated the validity of CMIP5 quite often, and I disagree with that. As she stated, some of the models that contribute to CMIP5 assume a 1% year-over-year annual increase in CO2, which is a gross overestimate, seeing as how observed increases are under 0.5% annually, and that this also doesn't model any political factors that would in the future reduce how that CO2 is affected, and then it assumes a 1% year-over-year increase for the life of the model, which grossly skews the future predictions of the model.
So for all those reasons,
You should support the opposition, because scientists using computer models are not able to accurately predict future climate events.
thank you very much. And now comes time for the audience to do their job, the judges to do